1. Forward time travel, future travel. Yes, traveling forward in time is possible according to physics. This comes from Einstein's special and general relativity. Time dilation, special relativity. When you move close to the speed of light, time slows down for you compared to someone at rest. Example: if you travel near light speed for a few years and return, you might age only 5 years while Earth aged 50 years. This is called the twin paradox. Gravitational time dilation, general relativity. Being in a strong gravitational field also slows your time relative to someone far away. Example: astronauts on the ISS age slightly slower than people on Earth. This was confirmed by GPS satellites, which need to adjust their clocks for both velocity and gravity effects. So, going into the future already happens, though tiny amounts for us. And it's supported by experiments. Key scientists: Albert Einstein, 1905 and 1915. Special and general relativity. Confirmed by experiments like the Haffel-Keating experiment, 1971, where atomic clocks flown around the world showed measurable time differences. 2. Backward time travel, past travel. This is where things get weird. Physics doesn't forbid it outright, but it's far trickier. Closed Timelike Curves, CTCs. Solutions to Einstein's equations, like Gödel's universe, 1949, show the possibility of loops in spacetime, meaning you could theoretically return to your past. Wormholes, hypothetical shortcuts through spacetime. If one end moves faster or experiences different gravity than the other, you could enter one end and exit before you entered. Proposed by Einstein and Nathan Rosen, 1935, the Einstein-Rosen bridge. Developed by Kip Thorne, 1988, for traversable wormholes. Tachyons, hypothetical faster-than-light particles. Could theoretically allow backward signaling in time, but no evidence yet. Problems: causality paradoxes. Grandfather paradox, if you go back and prevent your birth. Energy conditions. Wormholes require negative energy, or exotic matter, which we haven't discovered in usable amounts. Quantum instability. Stephen Hawking's chronology protection conjecture, 1991, suggests the universe may prevent backward time travel automatically. 3 equations and framework. Here are the main mathematical tools: special relativity, TGT, where dρ1 1v2c2, time dilation. General relativity, Einstein field equations, Gmn plus L Gmn 8pg c4 Tmn. Solutions allow for wormholes and closed timelike curves. Wormhole metric, Morris-Thorne. ds2x e2f r dt2.1 b r r dr2 plus r2 do2 4. So how could it happen in practice? Future travel. Travel near light speed in a spacecraft. Orbit near a black hole. Gravitational time dilation. Past travel. Hypothetically build a wormhole, stabilize it with exotic matter, move one end at high velocity or deep gravity. Step through and emerge before you entered. But as of 2025, we can only do forward time travel in small amounts. Backward time travel is purely theoretical. No experiments or machines yet. Would you like me to draw a simple diagram showing how forward and backward time travel would work according to relativity and wormholes? It would make this clearer visually. You said,
YouTube script, time travel, is it really possible?
background, futuristic graphics, clock animations, galaxy visuals. Narrator, you. Imagine waking up one morning, stepping into a machine, and suddenly finding yourself in the year 3025, or even back in the time of the dinosaurs. Sounds like science fiction, right? But what if I told you that science actually says time travel may be possible? Today, we'll explore what scientists say about traveling into the future, and even the past. So stay tuned till the end, because the reality is more mind-blowing than the movies. Part 1. Time travel to the future, 040 to 230. Animation, twin paradox, spaceship flying near speed of light. Narrator. Let's start with the future, because believe it or not, forward time travel isn't just theory. It's already been proven. Einstein's theory of relativity showed us that time isn't fixed. It bends and stretches depending on how fast you move or how strong gravity is around you. Here's an example. Imagine two twins. One stays on Earth, the other travels in a spaceship close to the speed of light. When the space-traveling twin returns, he might be 5 years older, while the Earth twin could be 50 years older. This is called the twin paradox. And it's real physics, not science fiction. In fact, we've tested this. In 1971, scientists flew atomic clocks on airplanes and compared them to clocks on the ground. The flying clocks actually showed different times. Even astronauts on the International Space Station age slightly slower than us on Earth. So yes, we can travel into the future, just very slowly right now. Part 2. Time travel to the past, 2:30 to 5:30. Background, wormhole graphics, black hole animations, grandfather paradox. Narrator. Now, let's get to the big question. Can we go backward in time? Here, things get complicated. Some solutions to Einstein's equations suggest it might be possible. Scientists call them closed Timelike curves. In simple words, these are loops in space-time that could let you return to the past. Another exciting idea is wormholes, shortcuts through space and time. Einstein and Nathan Rosen first talked about them in 1935, and later physicist Kip Thorne worked on the idea of making them traversable. Imagine walking into one side of a wormhole and stepping out before you even entered. But here's the problem. Wormholes would require something called exotic matter, a kind of negative energy we haven't discovered in usable amounts. And even if we had it, there's the risk of paradoxes. Like the famous grandfather paradox. If you go back and prevent your grandfather from meeting your grandmother, how could you even exist to time travel in the first place? Stephen Hawking, one of the greatest minds of our time, even suggested that the universe might have a rule called chronology protection, meaning nature itself prevents backward time travel. Part 3. The equations behind it, 5:30 to 6:30. Background, math equations fading in and out, clock spinning, futuristic theme. Narrator. Now, for those who love equations, the math behind time travel is deep. In special relativity, the formula for time dilation is T-T, 1, V2, C2. And in general relativity, Einstein's field equations even allow for wormholes and curved space-time. Don't worry if the math looks complicated, the big idea is simple. Time is flexible, not fixed. It can bend, stretch, and maybe even loop back on itself. Outrow, 6:30 to 7:50. Background, futuristic city fading into dinosaurs, galaxies, wormholes closing. Narrator. So here's the conclusion. Traveling into the future is not only possible, it's already happening on small scales. But traveling into the past? That's still a mystery. The equations suggest it might be possible, but the universe might have hidden rules that stop it. Who knows? Maybe in the far future, humans will figure out how to build a real time machine. Until then, the best time machine we have is our imagination, and science itself. If you enjoyed this video and want more mind-bending science explained simply, make sure to hit that like button, subscribe, and share this with a friend who'd love to time travel with you. And tell me in the comments, would you travel to the past or the future? Outro music plus